Hello students, this is Miss Dalton and this video is on simplifying rational expressions. So I want you to think back to when you first learned how to simplify fractions and you had, let's say these two examples. So you had 6 over 10, and so when you simplify that, what you're looking for is you're looking at breaking down the 6 into what two numbers multiply to give you 6. So 2 times 3 would be one example. And think of two numbers that would multiply to give you 10, 2 times 5. And what we're looking for is anything that we can cancel out. So we can divide out the 2, and so our simplified fraction would be 3 over 5. Now we can do the same thing with 60 over 28. If you think of breaking down 60 as far as we can go, the first thing I notice is that I can divide both of those by 2. So if I divide this one by 2 and the bottom one by 2, then I will have 30 over 14. I can divide them by 2 again, and that gives me 15 over 7. And 7 is prime, so there's no other way to break that down, so this would be my simplified answer. So we're going to follow this method as well when we are simplifying rational expressions. The first thing you're going to do is you're going to simplify completely by factoring the numerator and denominator. So the very first thing that you need to do is you need to factor the numerator and denominator completely if they are not already factored. Then you're going to cancel out common factors like we did here. 2 is considered a factor of each of them, and so we would cancel them out. Note that when factors cancel, the result is equal to 1, not 0. So if an entire expression cancels completely, the answer would be 1. Think of taking 8 divided by 8. You wouldn't say that that's 0. That's not 0. That is equal to 1. So the same thing happens if you have a polynomial. So let's say I have x plus 2 divided by x plus 2. Well, that whole factor cancels, but we don't want to say 0. That would just be equal to 1. All right, so let's start with two examples where you have a monomial divided by a monomial. What you're going to do is you're going to take the coefficients and you're going to simplify them first. So 28 and 35, both of those are divisible by 7. So if I divide this by 7, I get 4. And when I divide 35 by 7, I get 5. Okay? And then x to the third, x to the 5th, I want you to think about it this way. I have x times x times x. I have x times x times x times x times x in the denominator. And so 3 x's will cancel out, but you'll have 2 x's down there at the bottom. And so you're going to have a 4 on top in the numerator, a 5 in the denominator, and you'll also have x squared left over. Okay, so this would be simplified. Let's look at part B. 36y squared divided by 12y. Well, 12 can go into 36 3 times, and 1y can cancel with 1y here, and so you would end up with just 3y. All right, now let's look at some polynomials that have been factored. So in part C, they've already been factored for you. So you're going to just look for common factors. Well, 3x plus 5 is in the numerator and the denominator, so I can cancel all of that out. And these are not the same because one's a minus and one's a plus, and so we would leave it like that. We would say 3x minus 5 over 3x plus 5. And something that I get often is I will have people try to cancel the 3x and the 3x, okay? But I don't want you to do that. You need to think about this is one whole piece. So think of that minus sign and that plus sign like those are connected. You cannot break those up. They have to be exactly the same in order to cancel them. So we can't just take the 3x's and cancel because they are being connected. Think about they're holding hands. We cannot break them up. And so this would be your final answer. If we look at part D, we have factors x minus 2 that cancels, and that's it. So we would leave the x plus 3 in the numerator and then x minus 4 in the denominator, and this would be as far as we can go. Okay, now let's look at some examples that have not been factored. So the very first thing we're going to have to do is we're going to have to factor the numerator and the denominator. So I'm going to take x to the third plus 7x squared plus 12x, and I'm going to factor that. Okay, well, the first thing that I notice is I can divide out an x. Okay, so if I divide out an x, I'm going to have x squared plus 7x plus 12. And then this factors as well. So think about, you would take your a times your c, so that would be 12. What are factors of 12 that add up to 7? So you can see that 4 and 3 work. And since a is 1, I would leave my x, but my factors are going to be these numbers right here. So x plus 4 times x plus 3. Okay, so the numerator has been factored into that top line there. Okay, now let's take the bottom, the denominator. So it's a 3-term polynomial, so we need to take our a times our c, which gives us 4, and we're looking for factors of 4 that add up to -5. Well, that would be -4 and -1, and again, since I have an a value of 1, then those represent my factors, so I can just put them in the parentheses, x minus 4 times x minus 1. So that's how that factors. Then I'm going to look for anything that cancels. Well, notice that I have x minus 4 and I have x plus 4, but those are not the same. So actually nothing factors here. And so we would leave it as x times x plus 4 times x plus 3 over x minus 4 times x minus 1. Nothing cancels, and so we will leave it like that. Okay, let's go over to part F. X squared minus 4. Well, hopefully you recognize that as a difference of squares. That's x plus 2 times x minus 2. And so that's how that factors. And then x squared minus 3x plus 2. I'm going to just go straight to the factors. I'm going to skip doing the chart and everything. This would be x minus 2 times x minus 1. And if you don't know how I got those numbers, again, make your AC chart and you'll be able to find out how to get those factors. Now I do notice that my x minus 2's cancel, so this would stay as x plus 2 divided by x minus 1, and that would be your answer for this one. Okay, so we're going to work through several examples of this. You are going to need to know how to factor, and so hopefully you have gotten to be an expert with that, with all the practice we've been doing. So come to class and ready to work.